In this video, we'll look at a few of the many ways that we can represent functions. Using the analogy of a function being the vending machine, there are several ways we can write or visualize this relationship. We can list it simply as a list of if-then statements. If you press A1, then you get a Snickers bar. If you press B1, then you get a Mars bar. If you press C1, then you get a Milky Way bar. If you press D1, then you get a scrumdiddlyumptious bar. Another way to organize this with fewer words is to use a table. In this table, we will have one row representing the inputs, or the buttons, and a second row representing the candy. In this table, the relation between the input and outputs is denoted by the vertical columns. So this tells us that the A1 is paired with the Snickers bar, the B1 is paired with the Mars bar, and it's the same relationship that we had given up above, C1 and D1 still being paired with Milky Ways and scrumdiddlyumptious bars respectively. While this table is a horizontal table, and the relation between the inputs and outputs is the vertical columns, it is also possible that we have a vertical table, where the relationship between the inputs and the outputs would then be denoted by the horizontal rows. So it is possible that you would have either a horizontal or a vertical table. Another way of showing this same relationship between the buttons and the candies is as a diagram of two sets, with the arrows showing the relation between the inputs and the outputs. It's important to recognize the arrows go from the input to the output. But again, we still have the same relationship. A1 is paired up with Snickers, B1 is with Mars bar, C is with a Milky Way, and D is with a scrumdiddlyumptious bar. And finally, we could also list this as a set of ordered pairs. When we do this, the x-coordinate is the input, and the y-coordinate is the output. So instead of saying if you press A1, then you get Snickers bar, we would simply have the ordered pair A1, Snickers bar. These are only 4 of many ways that we can represent a function. As we begin to transition into functions that are mathematical and numerical in their basis, we will have other algebraic and graphical ways of representing functions as well.